Welcome to chemistry class. Today in this class we are going to discuss practical chemistry. Being this will take much more time, I have decided to make it as discrete parts. Okay, I will keep each part in the channel. Okay, so let us see qualitative analysis. Here, there are two types of qualitative analysis in chemistry. That is, qualitative analysis of organic compounds, qualitative analysis of inorganic compounds. Okay, so inorganic salts. Okay, so here let us see. In case of organic chemistry, we used to call it as compound. But in case of inorganic chemistry, a substance used to called as salt. Here, let us see what is the difference between compound and salt. If you can break a substance, if you can break a substance into consisting ions, it is to be considered as salt. If you cannot break a substance into constitutes by means of usual methods, it is to be considered as compound. Okay, so let us see about inorganic qualitative analysis in this video. Okay, so here I would like to explain how an inorganic salt can be analyzed by a student in the laboratory. Okay, so let us see about the analysis of inorganic salt by means of a systematic procedure. Okay, so inorganic salt. Okay, so each and every inorganic salt contains one anion and one cation. Okay, see here, what is anion? Anion means a negative charged part of salt. A negative charged part of salt is said to be anion. Okay, so what is meant by cation? A positive part of a salt is said to be cation. Okay, so let us see, according to the systematic procedure, how many anions are there and how many cations are there to be analyzed by the student of intermediate or class 12 or UG courses. Okay, see here the anions, the familiar anions is to be analyzed in the laboratory are CO3 minus 2. This is called as carbonate. Carbonate. Okay. Cl minus, this is called as chloride. Br minus, this is called as bromide. Okay. SO4 2 minus, this is called as sulfate. CH3COO minus, this is called as acetate. Okay. BO3 minus 2, this is called as B2O3 minus 2. This is called as borate. NO3 minus, this is called as nitrate. Okay, and in addition to that, phosphate is there. PO4 3 minus, this is called as phosphate. Okay, these are the anions. Usually a student need to analyze in the laboratory by following systematic procedure regarding inorganic salt. Now let us see about the cations. Okay, so see here the first cation is Pb plus 2. Okay, the Pb plus 2 here usually along with lead there would be silver also in the procedure, but in practical it is not possible to give the student being the silver salts are too much cost. So usually the lead will be appear Pb plus 2 Ag plus. Okay, so these two ions comes under first group cations. First group cations. Let us see Cu2 plus. Second group cation. Second group. Al3 plus, Fe plus 2, Fe plus 3. Third group cations. Third group cations. Okay, Zn2 plus, Mn2 plus, Ni2 plus, these to be considered as fourth group cations. Fourth group cations. Is it clear? Ca2 plus, Ba2 plus, Sr2 plus, Sr means calcium. Fifth group cations. NH4 plus, K plus, Mg2 plus. These to be considered as sixth group cations. Sixth group cations. Okay. So based on the reagents used to precipitate these ions or used to confirm these ions, these are divided into groups. Okay. Although they are in different groups in periodic table, it is not to be considered here, because as per the convenience of the student and the person who is analyzing salt, based on the regions used to identify and as well as used to confirm, the cations are divided into these groups. Is it clear? So other than these ions, there are several ions, but usually according to the syllabus of senior inter class 11, class 12 as per UG students, so these are the cations is to be given for analysis. Okay, these are the set of anions and these are the set of cations. Okay, let us see how you have to identify the ions present in the inorganic salt. The procedure can be divided for our convenience or for the convenience of analyst. The procedure can be divided into the following parts. Okay, so the procedure incorporated preliminary tests. Preliminary tests. See what information one can get by doing preliminary tests regarding inorganic salt. Okay, so let us consider the first preliminary test, the state. Here two observations can made usually, that is A, the salt, the given inorganic salt may be crystalline or amorphous. Crystalline means it will be like it will have a sharp edges. If there is the given salt or the given substance has composed by the tiny particles with sharp edges, that is said to be crystalline. అంటే మనం చేతితో ఇలా అంటే మనం గుచ్చుకుంటుంది అనమాట క్రిస్టలైన్ సాల్ట్ కనుక అయితే. ఓకే, అండ్ ఇఫ్ ఇట్ ఈస్ లైక్ ఎ ఫ్లోర్ అంటే బియ్యం పిండి లాగో గోధుమ పిండి లాగో కొంచెం మెత్తగా కనుక్కున్నట్టయితే దట్ ఈస్ సెడ్ టు బి అమార్ఫస్. ఇఫ్ యూ గివెన్ బై ఏ క్రిస్టలైన్ సాల్ట్, ఇట్ హ్యాస్ సమ్ గ్లిటర్, కొంచెం అది మనకు మెరుస్తూ కూడా కనిపిస్తుంది. సో దట్ ఈస్ ద ఫస్ట్ అబ్జర్వేషన్ రిగార్డింగ్ ఫిజికల్ స్టేట్. బీయింగ్ almost all salts are in solid state given to the analyst or students in case of the colleges, then there is no issue about is it solid or liquid or gas like that. Okay, only our observation is confined to is it crystalline or amorphous. Is it clear? Now let us see the another most important observation: color of salt. Color of salt. Okay, here you know that there are several colors in the nature, but some of the inorganic salts only have the colors because they are having the ions which can produce color due to electronic transition. Is it clear? Let us see the probable colors, okay, given to the student in the colleges. Okay, here, white. Okay, if the lemon salt is white color, that may contain, so I will take in tabular form. Okay, that may contain Pb plus 2, Zn plus 2, Ba plus 2, Ca plus 2, okay, Sr2 plus, Mg2 plus, NH4 plus, etc. Okay. So for detailed explanation as possible to me, I wrote this much of ions here. So then B. So next probable color is blue. If salt is blue in color, definitely it contains copper as cation. Okay, Cu2 plus. Usually Cu2 plus is to be given. Cu plus is also there, but it is most unstable. So most of inorganic salts of the copper contains Cu2 plus. Is it clear? Now let us see another color, green. If salt is green in color, then it should have Na2 plus. Okay, Na2 plus. The another color is brown. Okay. Salt is brown in color, there would be Fe3 plus. Okay. So another one is pale green. Pale green. So if salt is pale green in color, there would be Fe2 plus. Fe2 plus is the cation present in the inorganic salt. If salt is pink in color, Mn2 plus would be there. Let us see the third preliminary test, action of heat. Okay. So in this test, the student is to be taken a pinch of salt into a dry test tube, and it is the test tube carefully is to be kept in the oxidizing flame of Bunsen burner. Is it clear? So oxidizing flame of Bunsen burner means blue color flame. Blue color flame lo pettinappudu manaku em jarugutundi anedi observation. The following observations can be made by doing action of heat. Okay. Number 1, water droplets. If water droplets observed on walls of test tube, okay, so then one can assume that there would be ammonium ion, NH4 plus. Okay. If there is a rust color fumes, there may be nitrate, NO3 minus anion in the salt. Is it clear? Next observation, if white salt turns to pale yellow. Pale yellow. Okay. There may be lead in the given salt. Okay. There may be lead in the given salt. So, if there is no such type of observations, there is no issue. Okay. Then we have to proceed the another test. See here, the fourth preliminary test is flame test. Flame test. Okay. So in flame test, there are the following observations. Number one. So let us see how this test has to be done by the analyst. Okay. So here a pinch of salt is to be taken in a dry watch glass, or in any other a plate like apparatus, and then a drop of concentrated H2SO4 used to make it slurry. So then the slurry, a part of slurry is to be taken along with the test tube, and then it is to be kept in the oxidizing flame of Bunsen burner. Okay. So now after doing that, we can there may be following observations. If apple green flame, if apple green flame obtained, then one can assume that there is Ba2 plus. Okay, there is Ba2 plus. If brick red flame obtained, there is Ca plus 2. Okay, if one has completed this test as perfect as possible, the analysis of cation may be 50% completed in this test alone. Okay. See, if there is a carmine red, there may be K plus. Okay. If there is crimson red, so I will stop here with carmine red. So being the usual colors obtained in the inorganic salt analysis is these three. If there is no color, okay, if there is no color, the presence of these ions can't expect the presence of these ions. ఇవన్నీ కూడా ఈ కలర్స్ ఏవైతే ప్రొడ్యూస్ చేస్తున్నాయో ఆ ions అన్ని కూడా సాల్ట్ లో లేనట్టు స్టూడెంట్ కన్సిడర్ చేయాల్సి ఉంటుంది. So this is the first part of the procedure of inorganic qualitative analysis. The second part of systematic procedure of qualitative analysis of inorganic salt is dry tests. So these tests are also called as identification tests. So here one can identify the presence of anion, okay, in the given salt. Let us see, there are around 7 dry tests are there. See here, I will explain in easy manner. Okay. So now, among dry tests, the first test is test with dilute HCl. Test with dilute HCl. Here, the salt is to be taken, a pinch of salt is to be taken in test tube, and then it is added with dilute HCl. Okay, the addition must be in slow manner, then only one can observe the change. Okay, so here, if during addition of dilute HCl, effervescence observed, effervescence, Effervescence means bubbles అన్నమాట. కొంచెం vigorous bubbles వస్తే దాన్ని effervescence అంటారు. Effervescence observed. Okay, if effervescence is there, okay, then maybe here all the tests are useful for identification only. Okay, maybe carbonate. That particular salt may contain carbonate when effervescence observed during addition of dilute HCl to the salt. Okay. The second one, test with concentrated H2SO4. Okay. So a few drops of concentrated H2SO4 is to be added to the salt taken in a test tube. Okay. Then here there may be two observations, that is A, white fumes, B, brown fumes. These two observations will not appear at a time. Keep in mind, if there is white fumes, you can't expect for brown fumes. If there is brown fumes, you can't expect for white fumes. Okay. If white fumes is there, maybe Cl minus. Okay. Chloride may be in the given salt. If brown fumes observed, maybe Br minus, means bromide. Is it clear? So here, by doing these two tests, we can come to conclusion regarding carbonate, chloride, bromide. If there is no specific change taken place in the test tube, these three ions are absent. Okay, just I am writing only the positive observations here. Okay, next third one. Test with concentrated H2SO4 and copper turnings. Heating. See here, regarding simple salt, when the two tests are not given positive observations, then one has to go the third test, that is test with concentrated H2SO4 and copper turnings. Okay, so here the analyst has to take a salt in dry test tube, and then it is added with few drops of concentrated H2SO4, and then it is added with a small pieces of copper turnings, and then it is subjected to heating. Okay, అంటే ఒక డ్రై టెస్ట్ ట్యూబ్లో కొద్దిగా పించ్ ఆఫ్ సాల్ట్ తీసుకొని దానికి ఫ్యూ డ్రాప్స్ ఆఫ్ కాన్సన్ట్రేటెడ్ H2SO4 యాడ్ చేసి కాపర్ టర్నింగ్స్ యాడ్ చేసి హీట్ చేస్తే దెన్ ఇఫ్ రస్ట్ కలర్ ఫ్యూమ్స్ అపియర్, if rust color fumes evolve, okay, then there may be nitrate. Maybe nitrate. Is it clear? So when there is rust color fumes evolved, then there may be nitrate. If there is no such type of observation in the test tube happened during the addition of concentrated H2SO4 copper turnings followed by heating, nitrate is absent. Okay, if it is like this, then maybe nitrate. If it is not like this, absence of nitrate. Is it clear? Up to now, we have conducted identification tests for 4 ions, that is carbonate, chloride, bromide, nitrate. Okay. So, if there is no positive observation we have to search for remaining ions. Okay. See here, the fourth one. Test for acetate. Test for acetate. Okay. Here, the salt is to be taken in the test tube, and then a few drops of concentrated H2SO4 is added, and then it is added with a few drops of ethyl alcohol and subjected to heating. Then if there is vinegar smell, okay, acetate may be there. Okay, let us see. So here what we have to mix: salt plus concentrated H2SO4 plus ethyl alcohol, followed by heating. Okay. Then if there is a fruity odor, okay. So before, I think I say about that as vinegar smell. No, not vinegar smell. Exactly, if there is fruity odor, there may be acetate. Is it clear? So I am repeating again. So test for acetate. The salt is added with concentrated H2SO4, ethyl alcohol, and then subjected to heating. If fruity odor is there, then there may be acetate in the given inorganic salt. Okay. Let us see test for borate. Okay, so after confirming there is no acetate, if there is such type of observation, there is acetate. If there is no acetate, then you have to test for borate. Okay, so what chemicals you have to add during the identification of borate means? Here salt plus concentrated H2SO4 plus ethyl alcohol, followed by heating. Okay. So by doing this, okay, listen carefully. It is very important and beautiful test. Salt, at first salt is to be added with concentrated H2SO4 and then ethyl alcohol, and then it is to be subjected to heating. Okay. So during heating, the vapors will comes out. That vapors is named as ethyl borate, triethyl borate vapors. Triethyl borate is an ester. Is it clear? That vapors burns in green color if you introduce that vapors in the flame. Okay. So here, if when the vapors, okay, when the vapors introduce in flame, a green color appears. This indicates there may be borate. There may be borate. Is it clear? So the vapors are because of triethyl borate. The vapors are triethyl borate vapors. They burns in green color when they introduce in the flame. Okay. So that ethyl borate is ester. Keep in mind. So here up to now we have analyzed for almost 6 ions, I think, carbonate, chloride, bromide, okay, and nitrate, acetate and borate, okay. So see here, test for sulfate, okay, test for sulfate, SO4 2 minus. So here the salt is to be added with saturated BaCl2 solution, okay. Saturated BaCl2 solution or saturated barium chloride solution is an aqueous solution. It is prepared by adding excess of barium chloride to the water. If you observe in the bottle, some extent of barium chloride remains undissolved at the bottom of the bottle because it is sparingly soluble salt. BaCl2 is sparingly soluble salt, keep in mind. So, such type of solution, when there is some extent of barium chloride remain undissolved at the bottom of the solution, such type of solution is said to be saturated barium chloride solution. So, by adding that saturated barium chloride solution, the supernatant of that solution is to be added, keep in mind. So, when the supernatant of the saturated barium chloride solution is added to the salt present in the test tube, then if you get a curdy precipitate, that precipitate is to be considered as barium sulfate precipitate, okay. A curdy precipitate, that precipitate is due to formation of barium sulfate. If, okay, then maybe sulfate, maybe SO4 2 minus in the given inorganic salt. Is it clear? If there is no such precipitate, then sulfate is absent. Is it clear? Now let us go for another test for phosphate. This is most important test. Test for phosphate, PO4 3 minus. Okay. Here the test is to be conducted like this: salt plus ammonium molybdate. Ammonium molybdate solution plus HNO3 plus concentrated HNO3 and then subjected to heating. So if you fail to find remaining all ions, then you go for phosphate, okay. So during the identification of phosphate, the test is to be done like this. A salt is to be taken, a pinch of salt is to be taken in the test tube, and then ammonium molybdate is added, followed by addition of concentrated HNO3 and then subjected to heating. Is it clear? If there is a deep yellow color precipitate formed, deep yellow color, precipitate, okay, deep yellow color precipitate is formed, then one can conclude that there may be phosphate. There may be phosphate in the given inorganic salt. Keep in mind. And the another important thing is deep yellow color precipitate is due to formation of ammonium phosphomolybdate. Okay, so this compound is formed in the form of deep yellow color precipitate in the test tube. Okay, if there is phosphate in the given inorganic salt. So these are identification tests. The most important thing is ఈ మొత్తంలో ఏదైనా ఒకటి పాజిటివ్గా వస్తే మనం అక్కడితో టెస్ట్లు ఆపేయాలి. ఇంకా అక్కడి నుంచి మనం కన్ఫర్మేటరీ టెస్ట్కి వెళ్ళిపోతాం. దట్ ఈస్ ఇప్పుడు సిస్టమాటిక్ ప్రొసీజర్లో థర్డ్ పార్ట్ అనమాట, కన్ఫర్మేటరీ టెస్ట్స్ ఫర్ anions. ఓకే, సో హియర్ దీస్ టెస్ట్స్ ఆర్ ఆల్సో కాల్డ్ యాజ్ వెట్ టెస్ట్స్. వెట్ టెస్ట్స్ అంటే ఇక్కడ ఏంటంటే బిఫోర్ డూయింగ్ కన్ఫర్మేటరీ టెస్ట్స్ ఫర్ ఐడెంటిఫైడ్ anions, the analyst has to prepare sodium carbonate extract of given salt. So how the extract to be prepared? Let us see. Salt and Na2CO3 is to be taken in 1:3 ratio and 3/4 of the test tube filled with water and then boiled and then filtered. The filtrate is called as sodium carbonate extract. Okay, so during confirmation of anions, this extract is to be used for best result. Okay, usually in class 12 and intermediate, the instructor will suggest the students to use a salt solution directly, but for best result, this is the tradition to prepare sodium carbonate for confirmation. Sodium carbonate extract preparation is preferable. Okay, let us see how the confirmatory tests is to be done for the anions. Okay, see here. Number 1, for Cl minus and Br minus. Okay, for Cl minus and Br minus. Ante if the analyst has identified Cl minus or Br minus, he has to confirm the presence of Cl minus or Br minus in the given salt. Okay, so for this, the extract is neutralized with dilute HNO3 and then added with AgNO3 solution. AgNO3 solution. Is it clear? So the extract is to be taken in the test tube and the neutralization is to be performed. How one can know the neutralization is completed? During the addition of dilute acid to the extract, effervescence will stop because the extract has basic nature because of Na2CO3. When you add a dilute acid to that, neutralization will start and effervescence will stop. At the completion of neutralization, the effervescence will stop. Okay, then one can ensure that neutralization is completed. After that, the AgNO3 solution is to be added. Okay, so here usually there are 3 observations if I minus also in the syllabus. Okay, now we are confined to Cl minus and Br minus. Okay, so see here, if white precipitate formed, and it easily dissolved. in NH4OH solution. Okay, so white precipitate is formed and it is easily dissolved in NH4OH. Then Cl minus is conformed. Cl minus is confirmed. This is confirmatory test for Cl minus. Okay, the observation is like this. And then the another observation, if there is bromide in identification tests, okay, see here, if pale yellow precipitate formed and it slowly dissolved in NH4OH, then the analyst can confirm Br minus as anion. Okay, need not two observations is to be considered. For the ion which is present or which is identified in identification test or dry test, only the confirmation test is to be done. Is it clear? So here the important thing one has to observe, white precipitate and easily dissolved or rapidly dissolved in NH4OH, then Cl minus is confirmed. Is it clear? So if pale yellow precipitate and it is slowly dissolved in NH4OH, then Br minus is confirmed. If there is I minus, yellow color precipitate will formed, it doesn't dissolve in NH4OH. Is it clear? If I minus is there, usually in UG level and intermediate level, I minus is not there in the syllabus. Okay. If I minus is there, then what is confirmatory test? Yellow color precipitate formed, it doesn't dissolve in NH4OH. Okay, this is the confirmatory test for Cl minus and Br minus. Let us see the confirmatory test for nitrate. Okay. Confirmatory test for nitrate. See here. Here also the extract is to be taken in the test tube. Okay. So let us see the extract is neutralized with dilute H2SO4, then freshly prepared, keep in mind, freshly prepared FeSO4 means ferrous sulfate is added and then concentrated H2SO4 is added. Concentrated H2SO4 is added. Is it clear? So here this is the most important test in inorganic chemistry. Okay, the skill of analyst can be gauged by this experiment also sometimes. Okay, so here the extract is neutralized with dilute H2SO4. I explained that in case of confirmation of Cl minus and Br minus, what is meant by neutralization, how you can identify the neutralization is completed. Is it clear? So after neutralizing extract, then freshly prepared ferrous sulfate. Freshly prepared means the ferrous sulfate Fe2 plus ion is most unstable. If it is kept for a long time, it converts into ferric sulfate. Okay. So to avoid that, the ferrous sulfate solution is to be prepared at the time of testing. Is it clear? So that means freshly prepared ferrous sulfate. After adding freshly prepared ferrous sulfate solution, then concentrated H2SO4, keep in mind the conditions are important. For neutralization, dilute H2SO4 is to be used. For test, concentrated H2SO4 is used. Is it clear? Then brown ring will appear. Brown ring. Okay. If brown ring formed, NO3 minus is confirmed. Nitrate is confirmed. The brown ring will appear like this. Let us see. Consider this as test tube. There are two solutions. The brown ring will appear like this. Okay, between two solutions. Solution 1, solution 2. Okay, this is brown ring. Okay, when brown ring is formed, one can confirm the presence of nitrate in the given solution. When this test is to be done means, if there is NO3 minus in identification test only. Okay. Let us see confirmatory test for sulfate. Confirmatory test for sulfate. If there is a sulfate identified, if sulfate is identified in identification tests, then one has to confirm the presence of sulfate by doing this test. Okay. Here, extract is neutralized with the dilute HCl, keep in mind, with the dilute HCl, then added with saturated. I told what about the saturation, about saturation in identification tests. Okay, saturated BaCl2 solution. Saturated BaCl2 solution. The two reagents is enough here. The extract is neutralized with dilute HCl, then added with the saturated BaCl2 solution for confirmation of sulfate. Is it clear? So then the observation, if there is sulfate in salt, the observation is a white crystalline precipitate. If a white crystalline precipitate formed and it is insoluble in NH4OH solution. Okay, a white crystalline precipitate for sulfate. Okay, నేను ఐడెంటిఫికేషన్ టెస్ట్ చెప్పేటప్పుడు పొరపాటుగా కరడీ ప్రిసిపిటేట్ అని చెప్పినట్టున్నాను, దాన్ని కరెక్ట్ చేసుకోండి. ఇక్కడ కన్ఫర్మేటరీ టెస్ట్ ఫర్ సల్ఫేట్ కానివ్వండి, ఐడెంటిఫికేషన్ టెస్ట్ ఫర్ సల్ఫేట్ కానివ్వండి, అక్కడ ఫామ్ అయ్యే ప్రిసిపిటేట్ని వచ్చేసి మనం ఏమంటామంటే క్రిస్టలైన్ ప్రిసిపిటేట్ అంటాము. అక్కడ బేరియం సల్ఫేట్ క్రిస్టల్స్ ఫామ్ అవుతాయి. ఓకే, ఆ క్రిస్టలైన్ ప్రిసిపిటేట్ ఫార్ములా వచ్చేసి BaSO4, barium sulfate. Okay, so then we can confirm SO4 minus 2. Okay, so this is about confirmatory test for sulfate. Okay. for borate BO3 3 minus. The formula is ఈ ఫార్ములా కూడా నేను మీకు అయాన్స్ పేర్లు రాసేటప్పుడు కొంచెం పొరపాటుగా చెప్పినట్టున్నా, అది కూడా ఒకసారి చెక్ చేసుకుంటాం, వెనక్కి వెళ్ళి చేసుకోవచ్చు. The correct formula for borate is BO3 3 minus. Okay, so here this is nothing new, I think, because the identification test is equal to confirmatory test in case of borate and acetate also. Let us see. Extract is added with concentrated H2SO4 and ethyl alcohol C2H5OH, ethyl alcohol, and then heated. Okay, so if vapors and heated, if vapors burns with green flame when introduced with in flame. Okay, so మనము ఎక్స్ట్రాక్ట్ కి కాన్సంట్రేటెడ్ H2SO4 ఇథైల్ ఆల్కహాల్ కలిపి హీట్ చేసినప్పుడు వేపర్స్ వస్తాయి. ఆ వేపర్స్ ని ఇథైల్ బోరేట్ వేపర్స్ అంటారు అని చెప్పేసి మనము ఐడెంటిఫికేషన్ టెస్ట్ లో చెప్పి ఉన్నాం. ఆ వేపర్స్ ని కనుక మీరు ఫ్లేమ్ లో ఇంట్రడ్యూస్ చేస్తే టెస్ట్ ట్యూబ్ ని గ్రీన్ కలర్ గా మండుతుంది. Okay, that is confirmatory test for borate. Okay, vapors burns with green color. Okay, keep in mind ఆ వేపర్స్ పేరు వచ్చేసి ఇథైల్ బోరేట్ వేపర్స్, అదొక ఎస్టర్ అన్నమాట. ఓకే, దెన్ BO3 3 minus is confirmed. ఓకే, సో ఇక్కడ ఐడెంటిఫికేషన్ టెస్ట్ మన కన్ఫర్మేటరీ టెస్ట్ గా కూడా పనిచేస్తుంది. ఇది కాకుండా ఇంకొక టెస్ట్ ఉంది, బొరాక్స్ బీట్ టెస్ట్ అంటారు దాన్ని. అది కొంచెం కాంప్లికేటెడ్, ల్యాబొరేటరీలో మనం చేయడం అనేది చేయొచ్చు, బట్ ఇట్ విల్ టేక్ టైం. సో దీనైనా కూడా మనం కన్ఫర్మేటరీ టెస్ట్ కింద బోరేట్ కి కన్సిడర్ చేయొచ్చు. ఇస్ ఇట్ క్లియర్? Let us see the confirmatory test for acetate. So I think this may be we have completed sulfate, chloride, bromide, nitrate, borate. This is fifth test, I think. Fifth one, confirmatory test for acetate, CH3COO minus. Okay, here also the tests may be exchanged for identification and confirmatory. Okay, see here, the extract is added with neutral FeCl3 solution. Neutral FeCl3 solution. Okay, and then heated. Then a red color precipitate obtained. A deep red color. Obtained. Heating after addition of water it turns to red precipitate. Turns to red precipitate. Okay, this is the confirmatory test for one of the confirmatory tests of acetate anamata. The another test is oxalic acid test. If you rub the salt along with oxalic acid, it gives vinegar smell. Okay, so because of formation of acetic acid. Okay, If salt contains acetate, if you rub that salt with oxalic acid, and you can get vinegar smell. Okay, then that is due to as formation of acetic acid. అర్థమైందా? సో ఇప్పుడు ఇక్కడ చూడండి, ఈ రెడ్ కలర్ ప్రిసిపిటేట్ నేమ్ ఏంటి? ఫెర్రిక్ అసిటేట్. ఓకే, 3Cl minus ions replaced by 3 acetate ions. Okay, so let us see, then acetate is confirmed. Here option goes to analyst. If there are 2 or 3 or more confirmatory tests based on the availability of chemicals in the laboratory, he can choose what test is to be used as confirmatory test for such particular ion. Okay, confirmatory test for phosphate. Okay, so let us see, we have done identification test for phosphate by using HNO3 and ammonium molybdate. Okay, now we have to confirm the presence of phosphate by different tests. Is it clear? So here the extract is acidified with dilute HCl and then added with magnesia. Added with magnesia. Magnesia means it has a magnesium chloride as major component. Okay, if white precipitate is formed, phosphate is confirmed. Phosphate is confirmed. సో ఇక్కడ ఏంటంటే మనం ఐడెంటిఫికేషన్ టెస్ట్లో అమోనియం మాలిబ్డేట్ టెస్ట్ చేసాం కాబట్టి కన్ఫర్మేటరీ టెస్ట్లో ఈ టెస్ట్ చేస్తున్నాం. ఇఫ్ we identified by using this test, then we can use ammonium molybdate test in confirmatory tests. Okay, this is about confirmatory tests of anions. Okay, after seeing this video, the student or analyst can get idea about the following things. Okay, so while a simple salt or an inorganic salt contains anion and cation, okay, the analysis should be carried in 2 steps. At first, by following systematic procedure, anion should be confirmed. Okay, during the confirmation of anion, there are several steps. Okay, preliminary tests and dry tests and then confirmatory test. If analyst identified the anion in identification test or dry test, then only he has to proceed for confirmation of that anion. Okay, so after getting confirmation of anion, then he has to go to analyze cation. Okay, సో ఇంతవరకు నేను ఈ వీడియో అప్లోడ్ చేస్తున్నాను. ఆ తర్వాత నెక్స్ట్ క్యాటయాన్స్ వరకు సపరేట్గా ఒక వీడియో చేసి అప్లోడ్ చేస్తాను. ఓకే, సో ద పేషెన్స్ ఆఫ్ ద ఆడియన్స్ ఈజ్ ఆల్సో ఇంపార్టెంట్ వైల్ వాచింగ్ ద లాంగెస్ట్ వీడియో. ఓకే, సో I am breaking this video into 2 parts. One part for anions and the another part for cation. Okay, thank you. Analysis of cations in mixer analysis. Before going to analysis, let us see what is the grouping of cations in inorganic practical chemistry. Okay, so here, according to the systematic procedure, the cations are divided into following groups. The first group cations, in this group, Pb plus 2 and Ag plus is to be incorporated. Second group cations. This contains Cu2 plus and Pb plus 2, some sorts of Pb plus 2. Okay. Third group cations. So here this group contains Al3 plus, Fe3 plus, Fe2 plus. Fourth group cations. Zn2 plus, Zn2 plus, Ni2 plus, Mn2 plus, CO2 plus comes under this group. Is it clear? Fifth group cations. In this group, Ca plus 2, Ba plus 2, Sr plus 2 incorporated. Sixth group cations. This group contains NH4 plus, K plus, Mg2 plus. Okay. So after knowing the group division of cations in inorganic practical chemistry, one has to identify the cations, the group of cations present in the given salt. Is it clear? Let us see original solution. Before going to identification as well as confirmation of cations, one has to prepare original solution of given salt. Okay. Here original solution can be prepared or is to be prepared by using the solvent in which the salt has solubility. Okay. So here usually in the laboratories, academic laboratories, most of the salts are soluble in water. So original solution can be made by using water as solvent. Okay. So now let us see what is original solution. It is very simple. It is a clear mixture or homogeneous mixture. A clear or homogeneous mixture of salt and solvent. Okay. So usually the water is used as solvent. Okay. Such solution is called as original solution. Okay. So during the preparation of original solution, one has to ensure the situation in the test tube like this. Okay. So here one has to take salt and solvent, and the analyst has to ensure the mixture is homogeneous. Such type of mixture is called as original solution. In the upcoming explanations, I will use OS as shortcut for original solution. One has to done the identification, group identification of cations or confirmation of cations by using this original solution. I am repeating the making again. It is a clear mixture of salt and solvent, usually water. Okay. The situation in the test tube after making original solution will be like this, or should be like this. Okay. Let us see identification of first group cations, that is Pb2 plus and Ag plus. Okay. Previously I told that Ag plus is not to be given in the laboratories because the cost of the silver salts are too much. Okay. So during the analysis of salt, one can expect only Pb2 plus in first group. Okay. Let us see the identification tests for first group cations. this table, EXP abbreviated for experiment, OBS abbreviated for observation, INF abbreviates inference. Okay. Inference means simply speaking result. Okay. So now let us see the test for identification of first group categories. See here, test with dilute HCl. Test with dilute HCl. Okay, here the original solution of the given salt is to be added with dilute HCl. Okay, here I am taking OS for original solution. Okay, the expected observation if there is first group cations is a white precipitate is formed. Okay, let us see the first observation. A white precipitate is formed. I am writing the probable observations here. Okay, if a white precipitate is formed, then one can expect the first group cations in the salt. Okay, maybe first group cations. Okay, maybe first group cations. If there is no precipitate, then absence of first group cations. Absence of first group cations. Is it clear? Then the analyst has to go for identification of second group cations. Is it clear? The identification of second group cations, that is Cu2 plus Pb2 plus. See here, during the identification of second group cations, the following test is to be done by the analyst or student. Okay, see here. Original solution is added with dilute HCl followed by H2S gas. Followed by H2S gas. Okay. If precipitate is formed, if precipitate formed, there may be second group cations. Second group cations. Is it clear? If there is no precipitate, okay, second group cations are absent. Is it clear? Absence of second group cations. These are the observations during the identification of second group cations. Here, one has to take original solution into the test tube and then it is added with dilute HCl and then it is added by H2S gas. Okay. ఇక్కడ మనం ఏం చేస్తున్నామంటే ఎసిడిక్ మీడియంలో H2S గ్యాస్ ని కలుపుతాం. ఓకే, ఎసిడిక్ మీడియంలో H2S గ్యాస్ ని కలుపుతాం. ఇక్కడ ఫామ్ అయ్యే ప్రిసిపిటేట్ ఏమంటారంటే సల్ఫైడ్ ప్రిసిపిటేట్ అంటారు. ఓకే, సల్ఫైడ్ అంటే ఆ ప్రిసిపిటేట్ లో ఏముంటాయి S-2 అయాన్స్ ఉంటాయి. ఐ మీన్ H2S లో S-2 అయాన్స్ ఉంటాయి. అక్కడ వచ్చే ప్రిసిపిటేట్ ఏమంటారు సల్ఫైడ్ ప్రిసిపిటేట్. ఓకే, ఫర్ ఎగ్జాంపుల్ if copper is there, then one can get copper sulfide. Okay, if lead is there, one can get lead sulfide. Okay, సల్ఫైడ్ ప్రిసిపిటేట్ యూజువల్లీ సెకండ్ గ్రూప్లో కాపర్నే మనం ఐడెంటిఫై చేస్తాము, కాపరే ఉంటుంది అక్కడ, కాబట్టి క్యూప్రిక్ సల్ఫైడ్ ప్రిసిపిటేట్ అనేది ఫామ్ అవుతుంది. మోరోవర్ ఏ స్టూడెంట్ హ్యాస్ టు కీప్ ఇన్ మైండ్ ద సెకండ్ గ్రూప్ precipitates are sulfides. Okay. Identification of third group cations. Usually the most common third group cations are Al3 plus, Fe2 plus, Fe3 plus. Okay, so let us see how one can recognize the presence of third group cations in the given salt. Okay, let us see. Here original solution is added with NH4OH and NH4Cl. Here NH4OH is aqueous solution, NH4Cl is solid. Okay, so to the original solution, after adding an aqueous solution of NH4OH, it has been saturated with NH4Cl. Okay, so test tube bottom lo కొంత NH4Cl అనేది మిగిలి ఉండే విధంగా మనం యాడ్ చేయాల్సి ఉంటుంది. Okay, so here let us see what type of observations one can expect if there is third group cations. Okay, if a gelatinous precipitate formed maybe Al3 plus. Okay, second observation, if brown red PPT formed, brown red, PPT means precipitate, maybe Fe3 plus, keep in mind. Okay, if green precipitate formed, maybe Fe2 plus. Okay, usually as usual, if there is no precipitate, absence of third group, absence of third group. Okay, so here like this we can write third group. See here, there is absence of third group cations, one has to proceed for identification of fourth group cations. Okay, the most common fourth group cations given in the laboratories are Zn2 plus, Mn2 plus, Ni2 plus. Okay, nickel 2 plus. So these are the most common fourth group cations. While analyzing the salt for identification of fourth group cations, the procedure has to follow like this. Okay, so at first original solution is to be taken and then it is added with NH4OH, ammonium hydroxide, this is usually aqueous solution, and then it is saturated with NH4Cl, this is solid. Okay, and then this is added with the H2S gas. Keep in mind, during identification of second group cations, we have added HCl and then H2S. Okay, so there we have taken H2S in acidic medium. Okay. Here, while we are analyzing for fourth group cations, what we are doing, observe carefully, NH4OH, NH4Cl and then H2S is added. Here we are adding H2S in basic medium. Keep in mind, the fourth group cations precipitate as sulfides in basic medium. Okay. So here let us see the observations. If white precipitate formed, okay, so maybe zinc, maybe Zn2 plus. Okay. If black precipitate formed, maybe Ni plus 2 or Ni2 plus. Okay. So if brown precipitate formed, if brown precipitate formed, maybe Mn2 plus. If you do this test perfectly, you need not to confirm the presence of zinc, nickel and manganese, because in crystal clear manner you can get precipitates. Okay. If white precipitate is there, zinc sulfide. If black precipitate is there, nickel sulfide. If brown precipitate is there, manganese sulfide. Okay. If there is no precipitate, absence of fourth group cations. Okay. Absence of fourth group cations. If there is no fourth group cations in the given salt, one has to go for identification of fifth group cations, that is Ca2 plus, Ba2 plus, Sr2 plus. These are the most, Ca2 plus and Ba2 plus are most common cations given in the laboratories. Is it clear? Now let us see how the test has to done. See here, original solution and added with NH4OH and saturated with NH4Cl. Keep in mind NH4Cl is solid, and then added with NH4 twice CO3, ammonium carbonate. This is also aqueous solution. Okay. So original solution is first added with NH4OH and then saturated with NH4Cl and then added with aqueous NH4 twice CO3. Keep in mind. Then here, if white precipitate is formed, okay, here only one observation you can expect, two observations. If precipitate is formed, if precipitate is not formed. Okay. So let us see, if white precipitate is formed, maybe Ca plus 2 or Ba2 plus. So we are not talking about Sr2 plus right now, because usually it may not give in the laboratories up to UC. Okay. So maybe Cl2 plus or Ba2 plus. Let us see if no precipitate. Then what will be there? Absence of fifth group cations. Absence of fifth group. Okay. If there is no first group cations, second group cations, third group cations, fourth group cations and fifth group cations in the given salt, the analyst has to test for sixth group cations, that is NH4 plus, Mg2 plus, K plus. The most common cations of sixth group given in the laboratory is NH4 plus and Mg2 plus. K plus is very rare cation in the laboratories. See here how we can test for these cations. Okay, they are very simple. See here, for NH4 plus. Okay. So if you suspect that there may be NH4 plus in the salt, then what you have to do, let us see. Original solution is added with NaOH and then heated. If you get ammonia smell, if ammonia smell is there, if ammonia smell is there, then the presence of NH4 plus is confirmed. Okay. So here Nessler's reagent to test another confirmation test for NH4 plus, but sometimes it will cheat us. Okay. Nessler test is based on the reagent and based on the contaminants present in the salt, that may be given even though there is no ammonia in the salt. Okay, ammonium in the salt. But this is perfect test. Okay. So if you get ammonia smell from the test tube after heating the original solution with NaOH, then you can confirm the presence of NH4 plus. Is it clear? For Mg2 plus, okay, then if you add NaOH to the original solution, if there is white precipitate, then you can confirm the presence of Mg2 plus. The name of the precipitate is magnesium hydroxide. Okay, name of that precipitate is magnesium hydroxide. Is it clear? For K plus, if ammonia is not there, then only you have to do for Mg2 plus. If Mg plus 2 also is not there, then you proceed for K plus. Keep in mind. So here what you have to do, you have to add sodium tetraphenyl borate. Sodium tetraphenyl borate. Sodium tetraphenyl borate is to be added to the original solution if you have or if you suspect there may be K plus in the salt. Okay. See here, a white precipitate formed. If white precipitate formed, what is that white precipitate? Potassium tetraphenyl borate. Sodium will replace potassium. Okay, potassium will replace sodium. Okay. Then what is there? Potassium tetraphenyl borate instead of sodium tetraphenyl borate. Okay, the name of the precipitate is potassium tetraphenyl borate. What you are adding here? Sodium tetraphenyl borate to the original solution. Okay, then you can confirm the presence of K plus ions. Okay, so this is about identification of first 5 groups of cations, and if there is no first 5 groups of cations in the salt, Now then we have to proceed for sixth group cations like this. Is it clear? So మనం ఇక్కడ కన్ఫర్మ్ చేసేయచ్చు వీటిని. After group identification of cations, one has to confirm the ion present in the salt. If one has identified first group cations in group analysis, then he has to confirm the presence of the particular cation in the given salt. Let us see, if first group cations identified, then the confirmatory test should be done for the presence of lead. Okay, let us see here. The presence of lead confirmed by adding potassium iodide to original solution. Okay, original solution plus Ki solution. If original solution, if lead is there, when the original solution is added with potassium iodide solution, yellow precipitate will be formed. Yellow precipitate will be formed. Okay. On heating, bright particles, keep in mind, bright particles of lead iodide, bright particles of lead iodide, PBI, appear. Okay, పొటాషియం ఐడైడ్ తో ఎల్లో ప్రిసిపిటేట్ వస్తుంది. ఆ ఎల్లో ప్రిసిపిటేట్ ని మనం హీట్ చేసి కూల్ చేస్తే, ఓకే, అప్పుడు మనకు లెడ్ ఐడైడ్ పార్టికల్స్ అనేటివి మెరుస్తూ కనిపిస్తాయి అన్నమాట. ఓకే, దెన్ Pb2 plus confirmed. Okay, so this is confirmation test for lead cation. Okay, in group identification of cations, second group cations are identified, then one has to confirm the presence of second group cations in the given salt. Okay, the most common second group cation given in the laboratories is Cu+2. Okay, let us see the confirmatory test. Original solution is added with ammonium hydroxide, NH4OH solution, ammonium hydroxide solution. Okay, here if copper is there, Cu+2 is there in the given salt, at first blue precipitate is formed. Okay, with excess ammonium hydroxide, turns to okay, deep blue. Keep in mind, deep blue. Okay, here on adding limited ammonium hydroxide, if copper is there, blue precipitate is formed. When it is added with excess of ammonium hydroxide, it turns to deep blue color precipitate. Okay, then one can confirm the presence of Cu+2. one can confirm the presence of Cu plus 2. Okay. If third group cations identified in group identification, then we have to confirm the presence of the third group cation. Okay, there are three most common third group cations. You know that is Al3 plus, Fe3 plus, Fe2 plus. So in case of simple salt, only one ion among these three ions will present. Okay, so let us see what are the confirmation tests for those ions. Number one, for Al3 plus. If Al3 plus is there, then what will be happen? Let us see. Original solution added with blue litmus solution. Blue litmus solution, keep in mind, and added with ammonium hydroxide solution. If original solution is added with a few drops of blue litmus solution followed by ammonium hydroxide solution, if there is floating blue precipitate formed, Al3 plus confirmed. This is also called as blue lake test. Blue lake test. Is it clear? Floating, keep in mind, floating blue precipitate formed. Okay, during this test. If then Al3 plus is confirmed. Okay. If Al3 plus is not formed, అంటే మనకు ఐడెంటిఫికేషన్ లోనే తెలిసిపోతుంది. Al3 plus ఉంటే వైట్ జెలటినస్ ప్రిసిపిటేట్ వస్తుంది గ్రూప్ ఐడెంటిఫికేషన్ లో. Fe3 plus ఉంటే రెడ్డిష్ బ్రౌన్ ప్రిసిపిటేట్ వస్తుంది. Fe2 plus ఉంటే గ్రీనిష్ ప్రిసిపిటేట్ వస్తుంది. గ్రూప్ ఐడెంటిఫికేషన్ లోనే మనకి హింట్ అనేది వచ్చేస్తుంది. దాన్ని బట్టి మనం ఇక్కడ టెస్ట్లు చేస్తాం. ఓకేనా? సో ఇప్పుడు నెక్స్ట్ ఫర్ Fe3 plus, when original solution is added with potassium ferrocyanide K4FeCN6. Okay, potassium ferrocyanide. Okay, then if there is deep blue color precipitate, deep blue precipitate, okay, is found, confirmed. Okay, let us see the test for Fe2 plus. The test for Fe2 plus. Okay, here the same reagent, that is potassium ferrocyanide, is to be added to the original solution. Okay, potassium ferrocyanide solution is to be added to the original solution. Then if there is pale blue or light blue, okay, pale blue precipitate formed, then we can confirm the presence of Fe2 plus. Confirm the presence of Fe2 plus. Okay, like this we have to do the confirmatory tests for third group cation. If fourth group cations identified in group identification, then one has to confirm the presence of either ion of these ions. Okay, so the fourth group cations are zinc, manganese, nickel. Okay, so when it is a simple salt, only one of these ions will be appear. Okay, then now we have to confirm that ion. Let us see. For zinc, Conformation of zinc can be done by adding potassium ferrocyanide solution to original solution. Okay, original solution. It will give white precipitate if there is zinc. White precipitate if there is zinc. Okay, then zinc, we can say that Zn plus 2 is confirmed. Zn plus 2 is confirmed. Okay, this is confirmatory test for zinc. Okay, let us go for manganese. For Mn2 plus ion, manganese ion it is. Okay, Mn2 plus ion. So here original solution is added with NaOH solution. Okay, if there is manganese in the given salt, at first a white PPT formed. A white PPT, PPT means precipitate, okay, formed and rapidly turns to brown. And rapidly, అంటే oxidize అవుతుంది అన్నమాట ఇది. Rapidly turns to brown. Keep in mind, the final precipitate is brown. Okay, just it appear as white precipitate for a few seconds, and then it turns to brown. Okay, so then one can confirm Mn2 plus. Mn2 plus is confirmed. Okay, so this is about the confirmation of Mn2 plus. Okay, from Na2 plus of fourth group cation. Okay, fourth group cations. See here, during confirmation of Na2 plus, original solution is added with dimethyl glyoxide. Dimethyl glyoxide. Okay, followed by addition of NH4OH solution. Okay, see here, original solution is added with dimethyl glyoxide and then it is added with NH4OH solution. Okay, then if there is Na2 plus, the precipitate is in bright rose color. Bright rose color precipitate formed. Bright rose color precipitate formed. Okay, then one can confirm the presence of Na2 plus. Okay, so this is about the confirmatory test for fourth group cations. Okay, let us see if fifth group cations identified in group analysis of cations, then one has to do confirmation tests for Ca2 plus and Ba2 plus. Okay, so now let us see how Ca2 plus, the presence of Ca2 plus can be confirmed. Okay, see here, okay, for confirmation of Ca2 plus, the original solution is added with ammonium oxalate. I will write the formula here. Ammonium oxalate. Okay, ammonium oxalate. Okay, then the formation of white precipitate takes place Okay. The formula of this precipitate is calcium oxalate. Calcium oxalate. Okay. See here what is happening. The ammonium is replaced by calcium. Okay. Calcium oxalate. Ca2 plus confirmed. Ca2 plus confirmed. Okay. So now let us see. We have to check in another step also before confirming the presence of Ca2 plus. Okay. This precipitate is completely soluble. Completely soluble. When this precipitate is completely soluble only, we can confirm the presence of Ca2 plus. If it is sparingly soluble, it is Ba2 plus. Okay. So if it is sparingly soluble, it is Ba2 plus. Let us see. For Ba plus 2 also the same test. Okay. But I will write the another confirmation test for Ba2 plus. Okay. We can confirm the presence of Ba2 plus by using ammonium oxalate. Okay. But to avoid the confusion, I am giving another test for confirmation of Ba2 plus. See here. This is also very simple test. Original solution is added with potassium chromate solution. Original solution for confirmation of Ba2 plus. Original solution is added with potassium chromate. See the formula K2CrO4. Okay. Potassium chromate solution is added. Yellow precipitate is formed if there is Ba2 plus. Yellow precipitate. Okay. Let us see the formula of the yellow precipitate is BaCrO4. Okay. Here barium replacing potassium. Here barium replacing potassium. If such type of precipitate is formed, then the Ba2 plus is confirmed. Ba2 plus is confirmed. Okay. If group 6 cations identified in group analysis, then one has to check for those ions. Okay. See here, for NH4 plus. So here what are 6 group cations? NH4 plus, Mg2 plus, K plus. Okay. For NH4 plus, original solution is added with NaOH solution and then heated. Okay. If ammonia smell evolved, ammonia smell identification of ammonia smell evolved. So then presence of NH4 plus confirmed. Okay. So brown color ఇప్పుడు OS with the restless reagent. This is test 1. Consider this as test 1. Consider this as test 2. If original solution is added with restless reagent, if original solution is added with restless reagent, a brown precipitate will be formed. This is second one. A brown precipitate, but it is not to be considered as perfect test, being restless reagent may be contaminated, okay, in so many cases. So the first test is to be considered as confirmation test. So NH4 plus confirmed. Okay, if original solution is added with restless reagent, then a brown PPT is formed, NH4 plus is confirmed. Okay. Number 2, for Mg2 plus. Okay, so here this is also simple test. Original solution. OS means original solution. I am repeating again. Original solution is added with NH4OH. If a soluble white precipitate formed, a soluble white precipitate, PPT means precipitate, white PPT formed, then one can confirm the presence of Mg2 plus. Okay, name of that precipitate is MgOH twice, magnesium hydroxide. Here ammonia replaced by magnesium. Okay. Number 3, last cation of analysis. Okay. So this is also a 6th group cation, but it is very rare in laboratories. For K plus. This can be confirmed by adding perchloric acid. Perchloric acid. Okay. K plus can be confirmed by adding perchloric acid to original solution. Okay. A white precipitate formed. Okay. This name of this precipitate is potassium perchlorate. Okay. Then we can conclude that K plus confirmed. K plus confirmed. Okay. This is about the confirmation of 6th group cations. సో ఇప్పుడు మనం బాగా గుర్తుంచుకోవాల్సింది ఏంటంటే మనము అప్ టు క్లాస్ 12 అండ్ డిగ్రీ ఫస్ట్ ఇయర్ యూజీ ఫస్ట్ ఇయర్ వరకు సింపుల్ సాల్టే ఇస్తారు సిలబస్లో. సో ఒక సింపుల్ సాల్ట్లో ఒక యానియాన్ ఉంటుంది, ఒక క్యాటయాన్ ఉంటుంది. దానికోసమే మనం ఈ మొత్తం అనాలిసిస్ అంతా చేస్తూ వస్తాం. ఆఫ్టర్ గెటింగ్ రిజల్ట్ వీ హ్యావ్ టు రిపోర్ట్ దట్ ద ప్రజెన్స్ ఆఫ్ యానియాన్ ఈజ్ సో అండ్ సో, ద ప్రజెన్స్ ఆఫ్ క్యాటయాన్ ఈజ్ సో అండ్ సో. Then in higher studies they will give a mixture. Then there would be 2 cations, 2 anions up to UG level, and then in PGs more number of cations and more number of anions will be there in the mixture. Okay. సో ఇప్పటి వరకు మనం ఈ వీడియోలో మనం డిస్కస్ చేసినంతా కూడా సింపుల్ సాల్ట్ గురించే డిస్కస్ చేసాం కాబట్టి మొత్తానికి ఎన్ని ఆనియాన్లు ఉన్నా మనకు ఒక ఆనియానే కనిపిస్తుంది, ఎన్ని క్యాటయాన్లు ఉన్నా ఒక క్యాటయానే కనిపిస్తుంది. ఓకే. Thank you for watching.